Hi everybody, welcome to Unit 7, Day 2. We're going to be talking about the least squares line and finding a line of fit by hand. We're also going to be able to explain the real world meaning of slope and y-intercept. But first, a reminder from yesterday. Yesterday we learned about correlation coefficient. Remember, it's a number between -1 and 1. It tells how strongly correlated our data points are. It tells you how linear your data is, so if you know your predictions will be accurate. So positive correlation looks like this. It's got a positive slope. Negative correlation has a negative slope. The closer it is to a line, the closer it will be to either 1 or -1. So as one variable goes up, the other goes up. As one variable goes up, the other one goes down. The closer this is to a line, it'll be closer to +1. The closer this one is to a line, it'll be closer to -1. The other thing I want to remind you about is that correlation is different than causation. Just because two variables are correlated doesn't mean that one causes the other. There might be lurking variables, and we did talk about those yesterday. Lurking variable is something that there might seem to be one thing causing another, but the lurking variable is what is actually happening there. So moving on to our newer material today, we are going to be talking about the real world meaning of slope and y-intercept. And if you recall, slope is the change in y over the change in x. Notice how y is on the top and x is on the bottom. So to find the real world meaning, we're going to use whatever the units are for y divided by the units for x. So same thing as up here, y is on top, here y is on top, here x is on the bottom, x is on the bottom right there. So here's our example for today. We've got this graph here. We've got distance on our y-axis, gas in gallons on our x-axis, and we have this equation of this line right here, 28.8x plus 18.1. So in that situation, 28.8 is our slope, 18.1 is our y-intercept, and we call this a prediction line. Now technically there should be this little mark over the top of the y. This is read y hat, and it means that this line right here is a prediction line. If you can see here, it doesn't go through every single point, but we are using it to predict where our data might be. So again, here's your slope, 28.8 miles per gallon. You see how I did the y over the x, and then plus 18.1. That's our y-intercept. So, finding the real world meaning of slope and y-intercept. The y-intercept has an x value of, if you recall, 0. So the meaning for the y-intercept is that when the units for x are 0, then the y is whatever is remaining there, okay? The y is the remaining amount. So going back to our example, our y-intercept here is 18.1. So that means on 0 gallons of gas, we can go 18.1 miles. Now, you guys know that that's not possible. And remember that this is a prediction line. And sometimes our prediction line doesn't go far beyond our data. It doesn't make sense far beyond our data. For example, if you are looking at height and age, as you get to be 18, 19, 20 years old, you stop growing. So that line of fit would not make sense for somebody who is 45 or 50 years old, because it might maybe say that they're supposed to be like 8 feet tall. So you have to be really careful with prediction lines and make sure that the actual answers that you're getting make sense when you use them. So with the equation for the line of best fit, we can make predictions. Hold on here. The equation for the line of best fit. There we go. We can make predictions. Predictions within the range of collected data is called interpolation, and predictions outside the range of the collected data is called extrapolation. So you need to know these words. Interpolation means within the data set. Extrapolation means outside of the data set. And we are more confident when we have a high correlation and we use interpolation, and we are very cautious when we have a low or a weak correlation and we use extrapolation. So if you need a moment, take a moment to write these down, pause the video, write these down into your notes. And then when you come back, I'm going to have a slide that will help you see this a little bit better. All right, welcome back. So here's a table for you. If your correlation coefficient is strong and you're using interpolation, then you should be confident about the answer that you plug in. If your correlation coefficient is strong but it's extrapolation, then you should be cautious. Similarly, if your correlation coefficient is weak but you're using interpolation, you should also be cautious. And finally, if your correlation coefficient is weak and you're using extrapolation, you should not be confident in your answer. So when we ask you questions about how confident are you about your answer, this is the table that you need to refer to. So again, if you need to pause the video and write this down, or pause it and take a picture of it, go ahead and do that, please. All right, welcome back. So here's our example for today. We are looking at the combined SAT score and the first semester college GPA. So here's our prediction line. Y equals 0.001x plus 1.5. So now, first of all, what is the real world meaning of the slope? Well, let's first identify this as the slope. So our real world meaning means a GPA increase of 0.001 for each point of increase on the SAT. So again, using our units here, change in Y, first semester GPA, over change in X, combined SAT score. The real world meaning of the y-intercept, there's our y-intercept of 1.5. So when someone scores a 0 on the SAT, when X is 0, their GPA is 1.5. Take a look at this. Let's go ahead and try and estimate the correlation coefficient. Seems pretty linear. It's definitely positive. Somewhat strong, I would say. So your correlation coefficient, I would say, is about 0.8. I think when I calculated it out, it was a 0.76, so that's pretty close to 0.8. Predict the GPA of a person with an SAT score of 1900. So first of all, we have to figure out where that 1900 goes. We know it's an SAT score. So if you look here, SAT is on my x-axis. So I take this 1900 and I plug it into our equation for x. So that's going to look like this. Okay, so we're going to type that into our calculator. That went in for x. And when you do that, you get approximately 3.4. Next, we're going to predict the SAT score of a person with a GPA of 2.4. So now we know the GPA. Let's look up here at our table. GPA is going to go in place of the y, okay? So we're going down here. We're going to put the 2.4 in place of our y. So 2.4 equals 0.001x plus 1.5. Then we're going to subtract this 1.5 from both sides. When we do that, we get 0.9 equals 0.001x. Then we're going to divide both sides by 0.001, and we are going to get a score of 900. Now, I want you to pause the video if you didn't understand what I did here, and I want you to try and work them out, and then go back and rewind if you need help. The last question for today, which prediction are you most confident about and why? So let's go back to this table here. We had a strong correlation coefficient, but are we talking about interpolation or extrapolation? Because if we're talking about interpolation, then we should be confident. If it's extrapolation, then we should be cautious. So let's take a look here. 1900 or 2.4. So let's look at what one is in our data set. So here's our data set here. Okay, 1900 is very obviously here. So 1900 is within our data set. My next question is 2.4 within our data set? Well, we don't have any data that's anywhere near 2.4. So 1900 would be interpolation, 2.4 would be extrapolation. So we are going to be more confident about the 1900, about the number 4 here, because we are using interpolation. So again, interpolation would be within our data set here, so anywhere from about 1200 to about 2350. And then also interpolation would be anywhere from about 2.6 to about 3.8. Extrapolation is everything else. So if you had a question about 2.2, well, we don't have any data down here, so that would be outside of our data set. Another one is if you had a question about the combined SAT score of 1,000. Well, 1,000 is definitely not in our data set. That's way over here, so that would also be extrapolation. All right, what I need you to do today is I need you to do the worksheet 2 in your Unit 7 packet. Tomorrow we'll do more with using the calculator to find the least squares regression line, but after today you should be able to use the regression line to make predictions and identify if it's interpolation or extrapolation. All right, thanks for watching. Go do your homework.